Hi, Grace. Just want to talk to you about the rectangular prisms and how to answer questions that look like this. The rectangular solids, I guess they call it. So here's the problem I'm going to look at. There's a bunch of them like this. I think number 9 is like this, number 10 is like this, number 11, 12, 13, 14. A lot of them are like this. And there's a couple on the test just like this. So here's the problem. They've given us some information here. They've said that RS is 6, ST is 3, and SL is 4. So the height is 4, the width is 6, and the depth is 3. And I'm going to switch over to this picture here now. So I've attempted to draw this. You have to put up with my drawing a little bit. But here's the picture of the problem we're doing. And the question was, how far is it from N to S? What's that distance? So I'm going to draw that line there. That's what we want to know. That's what the problem is asking us to find. And with just the information we have, we can't do it. We don't know enough yet. However, I could draw another line right there, diagonal on the bottom. Right there. And what I end up with, and again, you're going to have to use your imagination a little bit here, but I end up with this right triangle that goes right through the middle of that cube, of that rectangular prism. So there's this right triangle there. And the reason that's at all useful is that we have a theorem about right triangles. It's called the Pythagorean theorem. And I'm going to take this right triangle here, and I'm going to redraw it. So I'm going to redraw it over here. We got that, and there we go. So I've redrawn this triangle right over there. Here's N, here's S, and we already know one of these lines. We know the up and down. We know the height of that rectangular prism, so that's 4. And if we wanted to use the Pythagorean theorem, maybe I should remind you, this is kind of an aside over here, that the Pythagorean theorem said if you have a right triangle, we'll say this is 3 and that's 4. This isn't going to be 3. I'm just making this up. If that's 3 and that's 4, the Pythagorean theorem says that if we take the two legs of a right triangle, 3 and 4 in this case, and we square them, 3 squared plus 4 squared. We're going to call this C. No, I'm going to call this height. That's called the hypotenuse of the triangle. You've probably heard that word before, hypotenuse. So if you square the two legs and you add them together, you're going to get the hypotenuse squared. And that's the Pythagorean theorem. So to finish this problem, 3 squared is 9, 4 squared is 16. If I add them together, I get 25. Now, if this side is 3, and that side's 4, there's no way this side is 25. It's way too big. So the hypotenuse squared, some number squared, is going to equal 25. You might already know this. The answer is 5. That 5 squared equals 25. If you didn't know it, let's say it was 125 or 625, and you didn't happen to know what the square or what number squared equals 625, you can take the square root of 25, the square root of both sides. Square and square root undo each other. They're called inverse operations, so they cancel each other out. And the square root of 25 you can plug into a calculator, and sure enough, we get 5. So that's a quick refresh of the Pythagorean theorem before we keep moving on over here. All right, so if we had this other leg, we could use the Pythagorean theorem and find what we want, the hypotenuse of that right triangle. So even though my picture isn't great, it is a right triangle. There we go. If I look back at my cube or my rectangular prism over here, there's actually another right triangle that I can use. This one on the bottom. So on the bottom of the rectangular prism, the bottom face, even though it doesn't quite look like a right triangle in my picture because I'm drawing in 2 dimensions, there is a right triangle on the bottom here. So I'm going to redraw that right triangle. Right, like this. So here's S again. That's that point. That's not a 5, it's an S. This side is 6. And even though my picture doesn't look like a right triangle, it is a right triangle. This side is 3. I know both of the legs of this right triangle. So I can use the Pythagorean theorem, like over here. 3 squared plus 6 squared is equal to, I don't know, we're going to call this E. Okay? And 3 squared is going to be, equals E squared. So 3 squared is 9, 6 squared is 36. I add those together, I'm going to get 45. Some number squared equals 45. I don't know what that is off the top of my head, and if you punch it into a calculator, you're going to get a crazy decimal. Do not write that decimal down. It's not important what the decimal is, and we don't care. E is the square root of 45. It's an irrational number. It's a decimal that never repeats, it never stops. It's like pi, goes on forever. But that's okay. That's okay. Because that's not what I want to know. I don't really want to know E. I want to know how long NS is. I need this number though because E, this line right there, that hypotenuse, that's the same leg over here. So what I've just found by doing the Pythagorean theorem is I found how long this side is. This side, this leg of that right triangle, is the square root of 45. And I'm just going to leave it as a square root of 45 because I don't care what the decimal is. All right, now we're going to do the Pythagorean theorem. Pythagorean theorem, it's a tongue twister, again. So you're going to do the Pythagorean theorem twice. And I'm going slow here. Eventually it does get faster. All right, we're going to do it again. 4 squared plus whatever this leg is squared. Square root of 45 squared. Don't let that freak you out. Just be patient with me. And we'll call this G. I want to find G. So I'm going to go G squared. You can call it whatever you want. You can call it X, you can call it lightning bolt, Christmas tree, whatever. It doesn't matter what you call it. 4 squared is 16. And here's where I said don't freak out. I told you a minute ago that square root and squared are inverse operations. They undo each other. It's kind of like adding and subtracting or multiplying and dividing. They're opposites. So the square root of 45 squared, the squared and the square root are going to undo each other. They're going to cancel each other away. And we're left with 45. And you can check that in the calculator. If you do the square root of 45 and then square it, you're going to get back to 45 again. And that's why I wasn't too concerned about the fact that this was some crazy decimal, because it's going to work itself out in the end. 16 plus 45 then is going to be what, 61? Don't forget that that is not the final answer. If this side is 4, there's no way this side is 61. Way too big. The square root of 61 is the final answer. That again is going to be some crazy unruly decimal, but you'll notice they have the square root right there, and hey, there's the 6. All you need is the 1. That's how you do this. And again, I took my time with it. It does go a little faster the more comfortable you get with it, but you're going to take whatever 2 numbers are on the bottom of that rectangle. You're going to do the Pythagorean theorem. You don't have to draw the picture, but you're going to do the Pythagorean theorem. Whatever you get, that's going to be the other leg of our second right triangle. So you're going to take your answer from that first Pythagorean theorem and do the Pythagorean theorem again with the height of that rectangular prism. Do the Pythagorean theorem again, and that'll be your final answer. Okay, hopefully that helps, and you can fix those mistakes on this lesson. When you're ready, or when you're done with these questions on the lesson, I'll reopen the quiz for these problems.